So does your Postgres also face performance issues when it goes into production? Do you always feel that you are handling the connection manually on the code logic? And still, even after optimizing and managing those connections on code logic, you still find that, your CPU and memory usage goes off the roofs? Or maybe if you're scaling it very well and you have the read-write replica split, even then you find, your application or the read replica of your application not be getting much of the load and the load balancing is not properly there and the read replica sits idle? If that's the case, probably this video is for you. So, hi everyone, this is Aditya Prakash and I work as a DevOps engineer here at GeekyAnts, and welcome to the GeekSpeak by GeekyAnts. So today we'll be tackling all of this. I'll be using AWS RDS, and as you have read, we'll be using a very well-known battle-tested tool called Pgpool-II, which will help us do all of the things that I just discussed. And secondly, we'll do all of this with very little code written and without changing any of the core code logic. So to begin with, this will be the topic for today. Pgpool-II with RDS, handling DB performance at scale. So what are the problems that usually one faces on the infra level when it comes to a Postgres database? The first problem being too many DB connections. So when it comes to Postgres, PostgreSQL creates a new process every time it creates a connection. Every time a client comes, it asks for a connection. It creates a brand fresh connection from the client to the DB. So each of the time that this connection is made, this is a high CPU and memory usage task. So during traffic spikes, you'll get a lot of connections and your DB will get overwhelmed. And your DB will spend much of the time handling the connection than doing the core DB logic work. So in that case, what can we do? So a prominent solution of what we can do here is maintain connection pooling. So what connection pooling will do for you, it will, create a certain amount of physical connections always active to the database, thereby saving that particular amount of resource usage every time a client application tries to connect to the DB. And clients will not directly connect to the DB. They will in turn connect to the connection pool. And one of the active connections from here will be given to the client. This way, what are we doing? First, we are saving the latency because the database has already certain few number of connections active and it's able to serve the data. And lastly, we'll be also protecting the database from getting overwhelmed from the n number of client applications. So here, whenever a client application comes, it will be given one of the active connections and the other requests or the sessions that are here will be queued up. So this way, connection pooling will help us solve the problem of too many DB connections. The next major issue that you might face is, for example, you go ahead and you, have multiple read replicas across regions. You have reached that amount of scale on an application where you have a requirement where you need n number of read replicas. Amazon RDS or, using write-ahead logs, you can easily establish those synchronizations. But how do you balance the load? How do you make the application requests a particular write request go to a write replica or a read request go to a read replica? How do you do that? Maybe you write the logic on the code, but even in that case, there'll be a sum of a complex logic. And even if you write there, you might still find that, some of your read replicas are a bit idle. So in that case, what we can do is have a proper load balancer in between that, separates the read-write requests to different databases. For example, you'll have a master database that will asynchronously replicate its data to a read replica. And whenever an request comes in, the load balancer kind of thing that's present here will divide your write and read request to the write replica and only read request to a read replica. Another point to add here, why is a read-write replica split required? Because a general rule of thumb says that in an application, the usual ratio between a read and a write is somewhere between 10:1. So for every 10 reads, there is usually one write. So you need n number of read replicas and you need a logic, some middleware here that helps you segregate smartly the queries that are coming to your databases. So is there a one-stop solution for this? A solution that solves all the problems that we just discussed, TLS, load balancing, handling of connection pools, a tool, that is a bit battle tested, something that's cloud agnostic, and also it removes all the overhead of writing these unnecessary logics on the code. So your dev team can focus on the core logic while you can implement this solution to, get all the problems that we just discussed sorted out. Yes, there is a tool for it. Enters Pgpool. I have extensively used it and it has worked out really great for me. So what exactly is Pgpool? As is clearly mentioned, Pgpool-II is a middleware that sits between a PostgreSQL client and the server. So all of the requests that your application is making to the database doesn't directly hit the database. So it will solve all the three problems for us. First, connection pooling. It will maintain certain number of connections active to which the clients can connect and then get their queries output from the database. Next, it will solve your read-write split issues. You can give the query to it. It will smartly decide whether it's a read query or a write query, and it will direct it to the particular read or the write replica. And lastly, it'll help us, maintaining something what you call as high availability load balancing, and at the same time maintain TLS connections between your database and the Pgpool-II instance. So in this particular demo, we'll be utilizing what you call as AWS RDS, because again, I have extensively used Pgpool-II with AWS RDS and it has worked really well for me. On the other hand, you can also use it. As I said, it's cloud agnostic. You can use it on bare metal servers as well. You can set up your own Postgres, get that replication and the synchronization up and running, and add Pgpool on top of it. In this demo, I clearly wanted to focus just on the powers and the things that Pgpool-II brings us on the table. But if you still want to have a look at how it works on bare metal, one of my teammates has written a very great article on this. We'll be linking that in the video description. So now coming back to the demo. So I'll give you a quick set of prerequisites of what I have in place for this particular demo. On AWS, I have booted a PostgreSQL database. Post booting the PostgreSQL database, I've set up its read replica. It's usually few clicks that you can utilize on AWS and get this master slave architecture up and running. So now coming back to Pgpool, for this demo, what I have done is I have written a basic Docker compose file. We have various components here. This component usually handles the connections. There is another one that handles the TLS. And there is another one that handles the load balancing part of, the separating the read-write queries amongst the various databases that you have booted. So we'll go one by one. So as you can see, I have defined Pgpool backend nodes. 0 is usually the write replica. This is the URL of my main write database. Then this is the URL of the read replica that I have. And these are the basic username and passwords that I have in place for this particular connection of Pgpool to AWS RDS. Also, I'll add few more things here. I have enabled TLS and I have given the global PEM file. This is, you can download this from the internet. You can put in a search as AWS RDS CA file. It will give you the certificates for each and every AWS region. It will also give you a global certificate, which you can use, that's region agnostic. So you can use this, and if I have this in place, all my all the communication that will happen between Pgpool-II and AWS RDS will be over TLS. Understood? So let's get started. And yeah, lastly, I'll have a 9191 port on which my Pgpool will be up and running. So I'll quickly do a Docker compose up. Yeah, so as you can see, you have two nodes that are up and ready. One is my read replica, which they're treating is as node 0. And next I have a read replica, which they are treating as node 1. So a write replica with node 0 and a read replica with node status 1. Now I'll go to a different terminal and I'm on the same server. I'll connect. This is the PSQL CLI tool that I'll be using to connect to the my Pgpool instance. So usually what you do, you connect to the Postgres database, but here you're not connecting to it. What you're connecting to is port 9191 on this particular server on which the Pgpool will be accepting your queries. Now let's log into this gold39. This is my password, and I have some queries written which I will copy and put this here. Okay, so this table already exists. What I'll do is I will create a separate table called, say, ABCD. So now if you see, the request has gone, if you see the last line, the request has gone to node ID 0. What was node ID 0? Node ID 0 was our write database. So node ID 0 received the command that is being used to write to the database. Next, what I can do is I can insert something into it, which is again a write operation. What I'll do is I'll do a clean here and I'll write this again. You can see again the write query has gone to the node ID 0. Now let me run a select query that will show you which node is accepting it for the read part of it. So I'll select from test. I'll run it few times. I'll use select now. I'll run it few times, and as you can see, it's divided. Some of the data is going to node 0, while you can also see some of the data going to node 1, which clearly shows that the read part of it is getting distributed between the two nodes. I'll run the select queries a few more times. Yes, again validated that it's getting divided between the read node and the write node. So this is where we have achieved TLS. TLS how? Because I had written the global CA-PEM file in my Docker Compose, which accepted the correct queries. Next, we also achieved load balancing. The read one's going to your read replica, the write one going to your master database. So we have achieved two of the things. Now the first problem, we'll come back to the first problem, that was connection pooling. So what I'll do is I'll keep the Docker Compose running on that terminal, and I will quickly show you how have I done it. So these are the ones that will help you create those connection pools around. So what does this Pgpool num-init children do? So this Pgpool is something you can call as maybe a receptionist. So here we have two receptionists available to take in the client connections. Each of the receptionists can have one particular connection active right now. So right now we have, so with the help of this particular thing, these two, if I multiply 2 into 1, I'll have 2 active connections running. And lastly, we have one Pgpool reserved connection. This is usually meant for admins or some important clients whom we want to, keep out of this circle, because they would always need a connection to connect to the Postgres instance. All right, I'll quickly get this validated for you as well. So if I now go inside, type my password, and I do show pools. Sorry. Yes, so you can see 4 records here. There's a question, why do you see 4 records here? You can do simply divide by 2. Why? Because for each of the connections, the Pgpool, has data for each of the nodes. So this is nothing but 2 number of Pgpool num-init children that we have, 2 into 1 for the number of connections each of those children can have, and into 2, that is to the number of nodes. So that is 2 into 1 into 2. That is why you're seeing 4 rows. I'll validate this for you as well. What I'll do is I'll stop this for now. I'll restart it again. Just give me a minute. It's getting stopped. Yes. I'll quickly do a Vim here. And what I'll do is I will change this to 2 backend connections per child. Right now it was 1. So now you should see 8 records there. All right. So basically I'll kill this. I'll get into it again. I'll do a show pool pools. Yes, as I said, you'll get 8 rows. So basically you have 4 connections only live, but for each of the node, there is a record present here, because of which we get 8 rows when we look at the number of pools that are active. All right. So right now what we did, we achieved the load balancing, we achieved TLS, and then we also achieved connection pooling. All right. So now coming back to this, where do you place this Pgpool-II tool? Right now in this demo, what did we do? We had Pgpool-II running as an instance on Docker Compose. I was directly using PSQL as the client, which was connecting to Pgpool-II, and then Pgpool-II was communicating with the AWS RDS Postgres. But in a real-time application, your application wouldn't be using PSQL to connect to Pgpool-II. So we'll discuss two of the scenarios that we usually have. One is, say, everything is on bare metal. You have your backend clients, your backend workers, your backend instances running on, say, EC2 machines or on-prem servers. And you also have databases. Databases can be anywhere. As I said, this approach can be cloud agnostic. You can keep it on AWS RDS. You can boot your own on bare metals. So Pgpool will rise somewhere in between as a middleware. All your backend applications, client, workers will connect to Pgpool, that is booted as standalone, as Docker, as a container inside Docker Compose, and then it can connect to your multiple database instances, and all the logic and all the configurations that we just discussed can be configured here. But because I started this talk with a discussion of DB at scale. So at scale, usually nowadays we don't prefer bare metals. We can move completely to Kubernetes. So in Kubernetes architecture, where do you usually place it? So this is I got this diagram from the internet, very well explained. So this dark blue box that you see right now is what you call as the PostgreSQL operator. You will find a number of PostgreSQL operators here in the market. The PostgreSQL operators, what it will do is it will set up the various pods of Postgres inside a cluster. It will keep the logic, it will keep the smart logic within it, where if a replica dies, it boots up a replica. If too much load comes, it goes ahead and scales up the application. When the load goes down, it scales down the DB part of the application and does all those complex things. So a PostgreSQL operator does this. What you can do is you can have a Pgpool-II pod on top of it. So whenever your application is talking to it, they are not talking directly to the DB replicas booted by the PostgreSQL operator. What they will do is they will talk to the Pgpool service. This Pgpool service will have Pgpool pods, which will then in turn connect to the primary and the read replicas that is booted in onto your cluster. So yeah, that's it. You can, in the similar way that I did, you can also utilize Pgpool-II and make your database layer of your applications faster, reliable, and perform better at scale. Thank you so much for watching. Please like, share, subscribe, and put down the questions in the comment and keep exploring. Thank you so much.